All right, so this is section 3.2 for anyone who missed this right before Thanksgiving break. We're actually going to do the notes a little bit out of order today because I want to kind of show certain aspects of this first. So look at your 3.2 notes, and then I want you to skip to number 3. So go in your 3.2 notes and then skip to number 3 in that section. So I'm looking at the one that says, write the equation of the exponential function containing the 0.04 and 5, 8.05. We just did this on our homework. So it says, write the equation of this exponential function. Remember, an exponential function is in the form of y equals a times b raised to the x. So we're going to use that in order to solve. The 0 point is helpful because it helps me find my a really easily. So I'm going to plug 4 in for y, and I'm going to plug 0 in for x. A and b are still a and b because I'm trying to find them. But really quickly, I see that b raised to the 0 cancels out, so I just get 4 equals a. Oh, nice, easy. Now I need to use the second point, the 5, 8.05, as my new x and y. And my 4 is the a that I just found, and all of those together are going to help me find b. So I've got 8.05 equals 4 times b raised to the 5th. Now, since I already have decimals, I want us to throw this in the calculator and keep getting decimals. We divide by 4 first. And actually, let me pull up my calculator. That might be helpful. So 8.05 divided by 4 is going to be 2.0125. Write the numbers right. There we go. Goes b to the 5th. Now we need to square root both sides, but it's not just a square root, it's going to be a 5th root. So the 5th root is going to cancel out that exponent. So 5th root of 2.0125. Now, do you guys know how to put square roots in the calculator that aren't a normal square root? Let's talk about it. Hit the math button. And number 5, mine says n and then it has a radical. Yours probably says x and then a radical. That's what we're going to click for this. Now, some of you might need to put your 5 in before you hit this number, but the way mine is, I can edit that like little tiny box above my radical, and I can put a 5 up there. And then I want to put my 2.0125 inside the radical. Yep. So I want you to try this because I want to be able to help you. Some of your calculators, you need to press 5 before you press math. Some of you guys need to press math first. There's a lot of options here. So go ahead and pull your calculator out. I'm going to walk around and make sure that you got it. And here, let me write my answer down before I walk away. B equals 1.15. So it's math again. Did you get it? Good. Any questions over here? Did you get it? You guys good? Get your calculator out. Okay, I'm not doing this. Where's this gear go? Yeah, so.
Click math.
Yeah, click math and then the 5th one. Good. Okay, no, yeah, actually, that's fine. Press there. Good. Press 5 first, because that's going to be what we watch in our radicals. Press 5, and then press math, and then come down there. Yes, that's going to make that 5 little. You see that? So whatever that like root you're taking, press that one first. And then type it in, and then do you get that?
Yeah.
Awesome. Okay, let me scroll out a little bit. All right, you guys all get A is 4 and B is 1.15. Awesome. Okay, let's finish by writing this as a big equation. So my equation is y equals 4 times 1.15 to the x.
Where's the A?
The A is 4.
Oh. So did you do B to fifth power?
Mhm.
Yes.
Okay. Can you try the next one? It's just like this. You guys try the next one on your own? I'll join you there in a second.
Try 4.
Try number 4. Mhm. It's just like the one we just did. I'm going to start doing 3 with you. So I've got 3 equals A times B to the 0. So I got A is 3, and then to find B, I'm going to have 1.49 equals 3 times B to the 4th. So we divide by 3. And I got 0.497 equals B to the 4th. So now when I do that cube root, or sorry, not cube root, we're going to do a 4th root now because the exponent was 4. So when you go to your calculator, either press 4 and then press math, or do your math and get your little radical and make sure that 4 is the little guy out front. 0.497, and so my answer is 0.84. So my equation is y equals 3 times 0.84 raised to the x. All right, what questions do we have yet? Nothing? Okay, I wanted to start there because we had done that before, right? I wanted to kind of remind us something that we already knew. The next problem is now talking about logistic functions. So we're actually taking the same concept of these exponentials, but instead of my equation being y equals a times b to the x, my equation is going to be y equals c over 1 plus a times b to the x. So that's my logistic general equation. Just like how when we had lines back in algebra 1, our line equation was y equals mx plus b. Earlier this year, we did quadratics, which was y equals a times x minus h squared plus k. These are all general equations that we've used. We just were practicing exponential for a while, and now we're in logistics. So this is the equation that we're using now. Okay, very similar to what we were doing, except I now have something called limit to growth. That's like our horizontal asymptote. So this number 40 is your C value. So I will have to give you your limit to growth, the number that goes in the numerator of the fraction. A common mistake is that everybody wants the initial value to just be your A, kind of like how it was for my exponential function. My first point was 0, 3, and 3 was my A. However, that's not going to work here with all the extra pieces. So let's think of initial value like an ordered pair. That's when you start. That's when your time or your x nothing has passed. So I'm at 0 for my x, and then your initial value is your y. So that's the first point that we're going to plug in with my C, and that's going to help me find A. Okay, so the general equation is y equals C over 1 plus A times BX. And I'm going to take out C. Ooh, that eraser was way bigger than I thought. C is 40 because that's what they told me. My limit to growth is my C, so C is 40. Hope everybody's with me. X is 0. Y is 10. This plus sign's all messed up. So we've got 10 equals 40 over 1 plus A times B raised to the 0. Any questions about that? Okay. This B to the 0 just crosses out, so I just have 1 plus A in the denominator. And in order to get rid of the denominator, let's cross multiply. So I'm going to multiply 10 times 1 plus A. So I'm going to get 10 plus 10A. And then 1 times 40 is just 40. Minus 10 from both sides, so I get 10A equals 30. And then divide by 10 on both sides. And A equals 3. So again, this is the equation that I told you we're going to be using now because we're in the logistics. Your limit to growth is always given to you. That goes in your numerator. I plugged in the point 0, 10, and I got out A equals 3. Now I'm going to use my limit to growth again, use the A I just found, and then use that other point that I gave you, the point 120. And I'm going to write this equation again, and that's going to help me find B. Hold on, Andrew. Thank you. Hey, have a great Thanksgiving. So my Y is 20, my limit to growth is 40. I've got 1 plus 3 times B, and it's raised to the second, oh no, sorry, the first power.
How do you do
20 was this point that was given to me, and that's my X. Now since I found A, I need to find B, and so I'm using that new point. So we're setting it up all over again with a new point for my X and Y. B to the first is the same thing as just B, so you don't need a 1 power with that B, but I do want to cross multiply again, so I'm going to do 20 times 1 is 20, plus 3 times 20 is 60B, and then equals 40.
Is that what you did on the first equation?
Yep, we cross multiplied. That's how I got 10 plus 10A. Good question. Minus 20 from both sides, so I get 60B equals 20. And then I divide by 60. While we're all tempted to go to our calculators, I want you to just think of it as a fraction. So 20 and 60 both have a 0 that cross out, and then 2 and 6 have a common factor of 2. So it comes down to be B equals 1/3. All right, so now I have A and B, and I was given C to begin with, so let's write my equation. I don't think I need this calculator. Y equals 40 over 1 plus 3 times 1/3 raised to the X. All right, good work. We're gonna do 2 more problems like that. Anybody have any questions yet? Okay, I'm gonna walk through the next one with you, and then the third one I want you to try all by yourself. So we're doing the exact same equation. My initial point, you can think of it as 0, 16 instead of 16, because that's gonna go in for my X and my Y. You good?
Gretchen's here.
Who's Gretchen?
Gretchen's here.
Oh, she's here at school? I saw Megan, Sarar, and Riley Maher earlier.
Oh, here?
Yeah. There's kids everywhere. Limit to growth is your C, so I've got 128 is my C. So I'm going to write 16 equals 128 over 1 plus A times B to the 0. And again, I use that point 016 to get there. So b to the 0 just cancels out. So I'm going to cross multiply. 1 times 16 is 16. 16 times a is 16a equals 128. Minus 16 from both sides, and I'm going to get 112. And then divide by 16, a equals 7. I speed through that because if you don't know how to do that at this point in our career, we're going to have a bigger problem. So I know you guys can all solve that. Just simplify.
So we multiply 16 times 16.
Cross multiply. Okay, that's my A. My C is still 128. And I don't know B. And the very last thing I need to do is plug in this new 0.5 for X and 32 for B. So 5 for my exponent for my B and 32 for my answer. I can't do anything besides cross multiply. So I get 32 plus 32 times 7, which is 224, b to the 5th equals 128. And then again, we minus and divide. So I minus off 32 and I get 96. And I divide by 224. And while we're all tempted to just go to our calculators, it actually simplifies really nicely to just be 3 over 7. And again, I just taught you how to do a 5th root in the calculator, but I think it's also fine to just leave it by hand. So I'm going to do 5th root of both sides. And you can actually just leave that answer as b equals the 5th root of 3/7. You can use that. It doesn't matter. Just, I know sometimes I tell you no calculator and sometimes I tell you yes calculator. So you can leave it like this if you don't have a calculator. And so my final answer, put it all together, y equals, my C was 128 over 1 plus 7 times the 5th root of 3/7 raised to the x. Okay. All right, flip it over. There's one more, and I want you to do that mostly on your own. As you flip it over, though, I gave the information to you a little bit differently. What there is your limit to growth? What's your C value? 20? And then which point are you going to plug in first? 0.5 is going to be the first point that we plug in to find A. And then once we have A and C, then we can plug 210 in for my X and my Y to solve from there. Go ahead and try that. Come on up. Be nice and crowded up here. It doesn't do that anymore. I did Zoom for like a whole year, and I knew how to do it. And then I got to school in August, and it like didn't do anything it used to do. I was like, what is happening? So now it's like this bootleg version of the notes.
Go to the A.
You should find, I thought A was 3. Did you find A to be 3?
I got 3.
Oh, yeah.
So then you plug 3 in.
The B disappears, right?
The B does disappear.
So I got 3.
So when you plug the second equation and you don't plug in 3.
You plug 3 in for A. All right, you can see how I found A and B. B was kind of messy. I got it to be the square root of 1/3. And honestly, I'm going to put it in like the rationalized version of the square root of 1/3. You don't have to rationalize it at this point. You can leave it as just square root of 1/3. But I know some people love to go to the calculator too. So if you go to the calculator, go all the way to that 0.55. That's the same as the answer I have right now. So my final answer is when I plug all of that together, I've got y equals 20 over 1 plus 3 times square root of 3 over 3 raised to the x. Again, inside that parentheses, you can put any of these B answers, and that's fine. Whatever floats your boat. All right, you guys ready to move on? Okay, we've got 2 word problems that I want to do, and then we're going to go back to the beginning of our notes. And you do need your calculators for these. So this first one says the spread of the flu, the number of students infected with flu at Springfield High School after T days is modeled by the function, and it gives us this big function. And it says, what was the initial number of infected students? How do we find the initial number? That's like the y-intercept. How would you find the y-intercept of something like this? Plug in 0. Good job. Thank you. Plug 0 in for t. Now, if I plug 0 in for t, this e raised to all of that nonsense is going to be like e to the 0, which just becomes a 1. So I can cross that out and think about my equation just being 800 divided by 1 plus 49, which is 800 divided by 50, which I believe is 16 students. So what they're saying based on this model is that on day 0, there were 16 students that were infected with the flu. Questions yet? Letter B says, when will the number of infected students be 200? Where does 200 go? Not for T, PT. Because T is in terms of time, so 200 is how many students. So we're going to say 200 equals this big equation, 800 divided by 1 plus 49 e to the negative 0.2t. And we're going to go plug this into the calculator. We're going to go graph these two. One of them is going to be your y1, one of them is going to be your y2, and we're going to go see where they intersect each other. So I just said 2 equals that big equation I had from the top. Let's see, I'm going to graph 800 divided by 1 plus 49e raised to the negative 0.2x. And then my y2 is going to be 200. If you don't have a calculator now to check, I'd go back and check this later just so you know how to plug it in and so you know kind of how we got to where we got.
What do you get?
E, if you press second, ln, it will give you E and it will give you an exponent for that E already. Find it?
Yes.
All right, so I'm gonna go to my window. What was the horizontal asymptote of this graph? Like what's the highest it can be?
300.
Not 300, not 16, 800. Say again? Never. 240. You're gonna make it? Yeah. It's class is still an hour. I know it's a special schedule, but it's basically a normal day. They just took 5 minutes from every class and called it a special schedule. All right, so the biggest it can be is 800. So what they're arguing is that there are 800 students at the school, so you can't infect, we're doing a population of the school, so we can't infect more than the people who are in the school. Now, I don't know how many days it's gonna go take. We can guess something small, we can guess something kind of in the middle. I'm gonna guess maybe like 20 and we'll see if it works there. If we need to make it bigger, we can. If we need to make it smaller, we can. I know though that the Y max should be 800 because that's as high as it's going to get. That's my limit to growth. So now I press graph. Okay, perfect. I see where they cross. Let's go find that intersection.
You see that?
Say again,
I don't see that. What's the-
is your window the same as mine?
Yeah, me neither. This is a straight line.
That's why.
Yeah.
What's the number on top of the E?
On top of the E is negative 0.2t. Go look at your equation. Did
Make
you?
sure it's not a minus and make sure it's a negative sign. That's what I.
Yeah, make sure your negative 0.02 is or negative 0.2 is a negative sign, not a minus sign. And then the other thing is you might need parentheses around the whole denominator because it depends on how your calculator reads it. It might read it as 800 divided by and then something else. And so it might just give you a line. I am going to write down the intersection while you guys find what's going on with your graph. It is 13.96, so I'm going to say about 14 days is how long it will take before 200 kids get infected. Anybody have any questions yet? The next part says the school will close when 300 of the 800 student body are infected. When will the school close? What do I do with 300? Not the horizontal asymptote. I think you have the right idea. It's just that horizontal line that we're going to see where it crosses. I'm going to put it over here for the y equals.
Can you show your window?
Let me write this down. So letter C is the exact same thing. I'm going to do 300 equals that equation, and then we'll figure out what that is. So my window goes 0 to 20 on the x's, and my window goes 0 to 800 on the y's.
And I put the 36.
Okay, let me come check. You might have So you don't have an X.
What's on the section? Yeah.
Yes. No, you don't have it.
Try to watch that. Oh.
Yeah, of course. There's so many little pieces here, so I want to make sure that we just catch all the things. And then make sure you find the point of intersection. I believe it's 17. It's like 6.9 something, so it's approximately 17 days. Anyone, can you confirm or deny? Intersection is 17.
For X,
Yeah, did you put 300 in for your other Y2?
I thought it was 200.
We did a new problem. So the next part, letter C, that's what we did for letter B. You're perfectly right for that. But then letter C says the school will close at 300.
So you just put 300 instead of 200.
Mm-hmm. Yep, and then you see it's a new intersection point. We were talking in the other class, that feels a little too close to home, doesn't it? A little too relevant. We always talk about how math like isn't relevant, but this is like a little too relevant. You're like not very funny. All right, let's do one more, and then I want to go back to the beginning of our notes. This one is super similar. Are you guys ready to look at this one? It says, what's the initial population of deer? What do I do to find the initial population? T equals 0. Very good, Callie. T equals 0. Which means that, again, I cross out this e raised to all of that crazy stuff because it's going to be e to the 0, which is just 1. So for letter A, P of 0 is going to be 1001 over 1 plus 90, which is 1001 over 91, which is 11. So at the very beginning, there were 11 deer in this park. The next part says, when will the number of deer be 600? Where does 600 go? P of t. Good. So that's my equals. So I'm going to say 600 equals, and I'm going to write the whole equation. And this is just like on the last problem where now we have to go to the calculator and graph it. Y equals, and make that 600. And I'm just going to manipulate this guy a little bit. 1001, 1 plus, it should be 90 e raised to the negative 0.2x. Okay. All right, let's go to my window. What's my y max this time? What's your limit to growth here?
Negative 8.
1001. Mm-hmm. Yep, so it's at least up to there. And then my x max, it's probably around 20, maybe a little bit bigger. I'm gonna guess 50 just to make sure that we can see it. Sometimes I guess like a little bit on the high end just because I'm like, I don't want to come back and play with my window again. So I'm gonna guess 50 and I'm gonna go press graph. Oh, perfect, I definitely see it. So now I'm gonna go find that point of intersection. And that is 24.5. And that measurement is in years, and we could say 24 and a half years. That's totally fine. 24 years and 6 months. That's a legit answer. So I'm going to say that 24 and a half years. And the last one, letter C, says, what's the maximum number of deer possible in the park? 1001. Good. There's not even any work to do. Letter C is just 1001 because that's my limit to growth. That's what they said we have to stay underneath. Okay. Once you finish with this problem, I want you to flip back to the beginning of your 3-2 notes because we've got 2 problems there to do, and then I've got 1 more word problem before I want to be done for today. I think so. We're about to find out, aren't we? I don't need my calculator for a couple minutes. Now you guys got 6 minutes before you got to go to band. Okay. All right, so number 1 for the very beginning of 3.2 says identify the following as growth or decay, give the initial value and percentage of growth and decay. Okay, so I want to remind you that what we have been using for our exponential functions is y equals a times b to the x. Okay, that's not wrong, but I'm going to replace some of those variables to make it make a little bit more sense in a word problem situation. So instead of y, I'm going to say p of t. And instead of a, I'm going to say p sub 0. So sub 0 means a subscript of 0 times a 1 plus or minus r raised to the t. So it has all the same parts as before. My y is the same thing as p of t. My a is the same thing as my p sub 0. My base is the same thing. My b is the same thing as my 1 plus or minus r. And then my t is the same thing as my x. It's all the same pieces. I just named them a little bit different to make sense in this kind of word problem. P of t is that initial amount. It's that initial volume. It's where we start. And r refers to my rate. Now I wrote plus or minus because when we are doing growth, you can think of it as plus. When we're doing decay, we can think of it as minus. When in doubt, you can just use plus, and then if you get a negative number out, then it's going to be a negative rate or a decay. So growth is when the base, this 1 plus or minus r, is greater than 1. So that means I had 1 and I added something to it. And decay is when you have a base that's less than 1. So that means I had 1 and I minus something off of it. So it's going to be less than 1. By just looking, we can figure out whether it's growth or decay. We need to do a little bit of math to figure out whether it's what percentage of growth or decay it is. Okay. So let's look at letter A. What's your initial value there? What was your initial value? 5,607 is your P sub 0. That's your initial value. And the base is what's in parentheses. Is that going to be growth or decay? Is it bigger than 1 or smaller than 1? It's smaller than 1. 0.963 is smaller than 1. So that's going to be decay. I'm going to set this. Who? Yeah. Okay. I'm going to set my base equal to 1 plus r. And I'm going to solve for that. That's going to tell you what your rate is.
Pardon this interruption. If at this time we could please have all the band members and the cheerleaders report to the Luck Activity Center. Please all the band members and cheerleaders report to the Luck Activity Center.
You can do the other part after the assembly. All right, so when I minus 1 from that, I get negative 0.037. And that negative just reminds me that it's decay. And then I can move my decimal place 2 places to get my actual percent. So its decay is 3.7%.
That's all?
That's it.
Oh, so the rate tells you it's growth.
Okay.
So the rate will tell you it's growth.
Yep. The rate can also tell you if it's growth or decay if you didn't want to look at it from there. All right, let's look at the next one. What's my initial value here? 3.75. Good. Based on my base, is it going to be growth or decay? Growth. It's bigger than 1, 1.072. It's bigger than 1. And again, we'll figure out exactly what my rate is by doing 1 plus r equals 1.072 and then minusing 1 off. R equals 0.072, so let's move that decimal 2 places to get 7.2%. All right, how are we doing? All right, flip your paper over, and we're going to use this exact same formula on the next side. So I'm just going to write it while I can still see it. And so those problems before, I gave you the formula. Now we have to write the formula based on given information. So I gave us initial value and how much percent we are increasing or decreasing per year. All right, so what's my, I got P of T, and what goes in for my P sub 0? What goes in for my P sub 0? 21. P sub 0 is your initial amount, so I'm going to put my initial amount of 21 in, and I'm going to do what? Am I going to do plus or minus? Why? Good, and so what am I going to add to 1? Just 0.21. Just move it 2 places. And then when it says per year, that means that I'm just going to raise it to the exponent of t. It can be per year, per day, per month, per minute, per eon. As long as you know what unit you're in, it's just going to be a normal t. That'll change in a minute, but we'll keep it like that for now. The only thing I'm going to do to simplify this is just to rewrite it where I have my 1 plus my 0.21 as just 1.21 raised to the t. Just simplified it a tiny amount. Okay. Similarly for the next one, what's my P of 0? 0.6, 1 plus or minus? Minus, and what's 3% as a decimal? 0.03, and then raised to the t. I can do 1 minus 0.03 though, so I've got 0.6 times 0.97 raised to the t.
Did the multiply that?
Nope, don't have to multiply anything. Just leave it like that. All right, the next two are funny in the aspect that they say the words doubling and halving, not increasing or decreasing by a certain percent. What does doubling mean to you? Times 2. That's a great way to think about it. I often think of it as increasing by 100%. Again, if you hate that, if you're like, there's no way I would think about that, just ignore it. I'll show you kind of a shortcut in a second. My P of 0 is going to be 6. And if doubling is the same thing as increasing by 100%, it's going to be 1 plus 1. Well, what is 1 plus 1? 2. So when I asked, what does doubling mean to you? And Seth said times 2, you can immediately just think that the base is going to be 2. Now, the last part is a little funny because it says every 3 days. It doesn't say every day or every year. It says every 3 days. When it has a certain time that it does it in, we're going to say t divided by 3, or you can say 1/3 t. It doesn't happen on the first day or the second day, but it happens on the 3rd. It doesn't happen on the 4th or the 5th, but it happens on the 6th. So in order to keep track of that, we have to make that a fraction so it doesn't quite go to like the number that we want it to until we get to 3 days. Every 3 days it does that. So this is my final equation. So I just did doubling is increasing by 100%. Next, I'm going to do halving, which is the same thing as decreasing by 50%. So if I had 4 and then I halved it, then I only have 2 things left. So if you think about it that way, you can think of it as 200 times 1 minus 0.5 or 1 minus 1/2. However, if you're like halving, you're like, well, that's 1/2 of that. You can just write it as 0.5 or 1/2. You can go directly there for your base. My initial value is still 200, but this time it's every 6 years. How do I write that as an exponent? T divided by 6. Good. Okay. The last problem I want to do is a word problem that makes us use this equation to write the equation for the word problem. So I want you to flip to be the last problem of that page that we just left off on. Okay, so let me write it again. P of t equals P sub 0 times 1 plus minus r to the t. The problem says the population of Smallville in the year 1890 was 6,250. Assume the population increased at a rate of 2.75% per year. What goes in for my piece of 0? Good, 6,250. What's my rate?
2.7,
2.75. Let's make that a decimal. And am I adding or subtracting that? Adding. So the decimal form of that is 0.0275. And then it's just being raised to the t. If I add that together, my final equation is going to look like this. All right, the reason we have to write the equation is for letter A, it says estimate the population in 1950, 1915, and 1940. If we started in the year 1890, what am I going to plug in for T to represent 1915? 25? What am I going to plug in to figure out what it is in 1940? So we started at 1980 or 1890, excuse me, and then we went to 1915. Not 60, 50.
Oh, because we're going from 1890.
Can you guys help me by plugging those in? Can somebody plug 25 in for T and someone plug 50 in for T?
To the 50th power.
To the 50th power.
264.
Yep, I'm gonna round that 4 up to a 5 because it's population, so it's people. So if you have point something of a person, let's round it up to a whole person. Joao, did you do 25?
Yeah.
Thank you.
I got 12,314.
Good, and we're gonna round that up to 15. Perfect. All right, awesome. So we just plug those in. The last part, letter B, says predict when the population reaches 50,000. Where does that go? Where would 50,000 go? PT, good. So we're going to say 50,000 equals this equation. 625, 50, 1.0275 raised to the T. Yeah.
You just plug that into the equation.
Yep, just plug those in for T. So we'll plug 25 in for T and plug 50 in for T. All right, I do want to graph these really quick. I still have like a minute.
We're on B.
Yeah. All right, so I've got my exponential equation for one of my y's. I've got 50,000 for my other y. I'm going to tell you right now that my y max needs to be pretty big. My y max needs to be at least to 50,000. So I'm probably going to make it like 70,000 so I can see a little bit higher over it. 7, E, 1, 2, 3. And then my x max, I'm going to go for 100 just so I don't have to do my window again based on time. So I'm pretty sure I should be able to see it here. Graph. Okay, perfect. If you have trouble with windows, please let me know. I can help you kind of talk through it. A lot of it's just kind of guess and check. And the longer you do it or the more you practice, the more you kind of know how big or how small to kind of check for. My intersection I got was x equals 76.6, so we'll round that up to 77. So after 77 years, we'll reach 50,000 people.
Pardon this interruption. At this time, we will begin moving to the
All
Wilkes
right.
Activity Center.